A student dilutes 50 milliliters of 2 molar hydrochloric acid to a volume of 200 milliliters. Find the final concentration. In order to solve this problem, we have to use the following equation. M1 times V1 equals M2 times V2. M stands for the molarity, or the concentration, and V stands for the volume. Now in this case, the volume can be in any unit that you'd like. Liters or milliliters are the most common. However, you want to make sure that they're the same on the left and right side. So if you choose to use milliliters, ensure that you have milliliters for both V1 and V2. Additionally, you want to make sure that your M1 and V1 are talking about the same time, so both initial values or both final values, and M2, V2 are also talking about the same time, so they be the other one. If we look back at the problem, a student dilutes 50 milliliters of 2 molar hydrochloric acid. So we can stop there and figure out what these two values are. So a student's diluting 50 milliliters of 0.2 molar HCl. They go together. That's what they're starting with. So they're starting with 50 milliliters. So we can say V1 is 50 milliliters of 2 molar HCl. So that's M1. To a volume of 200 milliliters. So that's their final volume. So V2 is going to be 200 milliliters. We could have also solved this in liters. We just need to make sure both V1 and V2 would have been in liters. Since they're both given to us in milliliters, we'll solve it like that. Find the final concentration. So we are not given M2. In order to solve these problems, you are always explicitly given or have the information to find 3 out of the 4 variables. Here they just gave it to us explicitly. So we can either plug this directly into the equation, or what might make it more straightforward is, while they're still variables, we just rearrange them to solve for M2. To solve for M2, we need to divide by V2 on both sides. So that'll give us M1 V1 over V2 equals M2. Now we can easily plug the values in for the variables. M1 we said was 2, V1 is 50, V2 is 200, and that'll give us our answer for M2. When we do this math, we will see that M2 is equal to 0.5 molar. Now if you want to check your work, you can plug M2 in for this equation and see if they equal each other. Let's look at another problem. How much 6 molar NaOH is needed to prepare 250 milliliters of 1.5 molar NaOH? So again, our equation here is M1V1 equals M2V2. And if we look back at the problem, how much 6 molar NaOH, so we can say that is going to be our initial molarity. So M1 is 6 molar, is needed to prepare 250 milliliters of 1.5 molar. So we don't know how much of the 6 molar NaOH there is. So that's what we're solving for. That's V1. And that means M2 is 1.5 molar and V2 is 250. We also know that they should go together because it says 250 milliliters of specifically the 1.5 molar. So we know that they're both going to be the final values. Now I'm going to solve this slightly differently. Instead of rearranging the variables, it might be easier to just plug things in. So we know M1 is 6, V1 we don't know, so we'll keep it as V1, equals M2, which is 1.5, and V2 is 250. We can do 1.5 times 250, giving us 6V1 equals 375. We can divide both sides by 6 and get V1 as 62.5. Now, what unit are we going to give it? We have 250 milliliters, and that's what we have for our V2. So our V1 is going to be 62.5 milliliters as well. Let's look at one more example. A solution of 0.45 molar KCl is diluted from 85 milliliters to 500 milliliters. Find the final concentration. So if we reread that, we have 0.45 molar of KCl is diluted from 85 milliliters. So that's the key word, from, telling us that the 85 milliliters is our V1. And that is the initial solution of 0.45 molar KCl. That's with an initial concentration of 0.45 molar of the KCl. So we know our M1 is 0.45. Our final volume is given as 500 milliliters, and we just need to find the final concentration, or M2. If we plug it into our equation, we have 85 times 0.45 equals 500 times M2. When we simplify this, we get 38.25 equals the 500 M2. We divide both sides by 500, and M2 is equal to 0.0765 molar. Thank you for watching.